Hello everyone, and today we will be solving this by using the telescoping series. And first to do this, I will use the by-parts rule, okay, which that means from 3 over n times n plus 1, I will change that into a over n plus b over n plus 3. The denominators can change, okay, it does not matter, but if we do that, a and b, the values of a and b is gonna change also, which that also doesn't matter, so I like to keep it this way. So yeah, well, first to find the value of a and b, I will multiply n times n plus 3. Okay, when I do that, when I times n plus 3 onto here, we get 3 is equal to a times n plus 3 and plus b times n. Now, when I set n is equal to 3, then we get that b is equal to minus 1. Why? Because n is equal to minus 3, put it in there, that's 0 times a is equal to 0, so that's nothing. And when n goes into here, we have 3 is equal to minus 3b. So b has to be equal to minus 1. Okay, so now when we set n is equal to 0, then we have that a is equal to 1. Because 0 times b is equal to 0, but putting it in there, we have that 3 is equal to 3n. 3 times a, and a is equal to 1 from this. Okay, so now the values that we got for a and b, I will put it in there, which we get from the summations, when n is equal to 1 through infinity of 1 over n minus 1 over n plus 3. I will also rewrite this as limit of n approaches to infinity. We have summations from when n is equal to 1 to m. And those just stays the same. What can we do? Well, now we just solve for this. Okay? Starting off, we have n is equal to 1, so put it in here and here. We have 1, okay, so this is equal to 1 over 1 minus 1 over 4. That's our first set, and we will have many sets. Like, now we have that n is equal to 2, we have 1 over 2 minus 1 over 5, and then a plus 1 over 3 minus 1 over 6, plus 1 over 4 minus 1 over 7, plus 1 over 5 minus 1 over 8, plus 1 over 6 minus 1 over 9, plus 1 over 7 minus 1 over 10. Okay, you guys should write many as sets as you guys want until you guys figure out the pattern on which way, like how numbers can cancel off on each other. Okay, sets will go on through infinity. Okay, but wait. When n is equal to 1, we have this. When n is equal to 2, put it in there. Of course here, but I will only say for this one. When n is equal to 1, we get this. When n is equal to 2, put it in here, we get this. When n is equal to 3, put it in here, we get this. When n is equal to 4, put it in here, we get this. All the way up until m. Okay, so now we put m onto here and here. When we do, we get, okay, I'll put it right here. 1 over m minus 1 over m plus 3. Now to really show you guys that this is our last set, I will write 2 more sets right here and here. Okay, so let's do it. Well, let's just imagine, okay, that this set is equal to this set. Okay, so m is equal to, but the set before that is this, and there are 2 placements that we can have in any set, which is the front set and second set, and the front set 1 over m, 1 over 2. The set before the set we are doing right now, the front number is minus 1 from our previous one, which that would make us 1 over m minus 1. And then from any set, so for example, our first set, the denominator has been added by 3. So plus 3 here, plus 3 here, plus 3 here, plus 3 here, and yeah. So now plus 3 here, we have 1 over m plus 2. And then now you guys can just see the pattern that the set before this one is going to be m minus 2 and then a, minus 1 over m plus 1. Okay, now let's figure out how things cancel off. Minus 1 over 4 can be canceled off by 1 over 4 and 1 over negative 1 over 5 and 1 over 5, negative 1 over 6 and 1 over 6 and negative 1 over 7 and 1 over 7 and then negative 1 over 8 by the future 1 over 8 and then negative 1 over 9 by the future 1 over negative 1 over 9 and negative 1 over 10 by the future negative 1 over 10 and yeah. Okay, let's figure out how we did that. As I said, there are two placements that a set can have, okay? Which is the front number and the back number. How we canceled off negative 1 over 4 and 1 over 4 was from our set number 1 of the back number, okay? So the back number, it skipped one set, okay? So we will just put one set. Okay, so again, this is our first set. From the back number, we skipped one number, and then from our next set, we canceled off by the front number, okay? So front, one set, back, one set, front, okay? Back, one set, front. So back number, skip one set by the front number. Wait, this one. Wait, no, I made a mistake. It is actually skipping two set, my bad. It is skipping two set, okay? So back number, skip this set, and cancels off by the front number, okay? And then I can do the same thing with negative 1 over 5, which is this, negative 1 over 5 is the back. Skip one set, two set, and then our next set by the front number. Cancels off 1 over 5. Okay, and now negative 1 over 6, that's the back number. Skip this set, then cancel let off by the front number. And then negative 1 over 7, that's the back number. Skip one set, two set, and then minus off this. And then, yes, you guys can see what I'm doing now. And now I can use this process to eliminate some of this, okay? Let's just imagine there is a set here, which we have not drawn, but there is because it's before this one. This is the back number. We don't know what it is yet. Okay, so this is the back number. Skip this set, and then cancel it off by this and this. Okay, and then we can cancel this because we will have a set here and another set here. So for example, the back, which is going to be this number here, and then we're going to skip one set, two set, and then cancel it off by the front number, which is this. So this cancels off by this. And then we can also cancel this off from this number, okay? So this is the front number, back number, yeah, back number. This is the back number. Skip one set, two set, and then the front number next. So this cancels off by this, yeah. And there is no more things we can cancel out. That means our final, we get a step closer to our answer, which is as limit of m approaches to infinity, we have 1 plus 1 over 2 plus 1 over 3, and then a minus 1 over m plus 1, and then another minus 1 over m plus 2, and then another minus 1 over m plus 3. Okay, it says that as limit m approaches to infinity, that means this is going to be 0 because it's 1 over infinity. 1 over infinity is equal to 0. 1 over infinity is equal to 0. So our answer is 1 plus 1 over half plus 1 over third. That is equal to 11 over 3. Wait, no. 11 over 6. That could have been bad. Thank you guys so much for watching my video. And if you guys have any questions, let me know down in the comment section because I will answer it as soon as I get your message. See you guys in the next video and bye.